Yeah, let's just get started with this. So, yeah, just keep talking. All right, so this is what we're going to cover today. The first thing we're going to do is we're going to do a little review of Sharphound. Sharphound's been out for quite a while. In fact, it was released at DerbyCon 2 years ago, and there's a lot of misconceptions about what it does, how it works, that kind of thing. So we just want to cover some of that and like clear up some things that people might not know about. And then we're actually going to walk through an attack path that's going to cover a lot of the new stuff we've added recently to give people an idea of like how this would look in a real environment with some of the new cutting edge like hotness that people have released and we've integrated into the Bloodhound project. So this is us. I'm Rohan Vazirker. I go by @CaptainJesus on Twitter.
I'm Andy. I go by Waldo on Twitter. There are more chairs at the front if you're standing in the back and need a seat.
Yeah, that's enough about intros. All right, so Sharphound, how does it work? Poorly most of the time, but so yeah, it's getting better as time goes, but like a fine wine. So at the most basic level, this is our workflow with Sharphound. You give Sharphound a list of options that you want to enumerate, and we basically turn those into tasks. We query LDAP at the domain controller level, and we ask for the set of data that we need to accomplish that task. And we do this by taking each individual task and mapping it to an LDAP filter, and then we join all those LDAP filters into the Franken filter, and it looks really, really disgusting if you ever look at it, but it works, so I'm not going to change it because you don't mess with what works. We take all the data that gets returned from LDAP and we feed into a giant pipeline. And the pipeline basically just looks at the type of data that comes back and does actions based on what it is. So for each object, we'll run a specific set of API calls or data processing to make sure that we get all the information we can out of each different type of object. So there's a lot of different collection methods in Bloodhound. I'm actually going to cover a few that we think are really interesting that maybe people don't know about. You invoke a different collection method using the collection method or tax C flag when you run sharphound.exe. It allows you to specify what is collected, and it has a lot more granularity than people really think it does, because most people tend to run it either with the all flag or the default flag, which is fine because that's why those flags were introduced. But we want to kind of like dig in a little bit and talk about these like three main ones that people run and why they're useful. And those three are all, default, and DC only. All right, so default collection, this is actually probably where people start. They just run sharphound.exe, and it goes to work, and it collects a whole bunch of stuff and gives you some cool JSON files. This was what we originally started with when we released Sharphound, and really the Bloodhound project. This is kind of Bloodhound 1.0. It's pretty outdated at this point since we've added so much stuff since then. But really all it collects is a group membership, local groups on hosts, session information, and trusts. Now, if you're familiar with what the schema looks like today, that's missing like probably 10 different edge types that have been added between ACLs and some cool special execution rights and stuff like that. And when you run the default collection method, we touch domain controllers for LDAP. And we touch every computer on the domain for local group information and session collection. Now, that's a lot, but I'm going to make the argument that if you're going to run default collection, there's no reason you shouldn't run all collection. So, Sharphound taxi all is the way a lot of people end up running Sharphound after they've kind of dug into it a little bit. And this covers almost every single collection option that we have. The only one that's excluded by default is the logged on collection method. We exclude that because you need privilege to run that, and frequently we're running this as like red teamers and we don't have privilege, but we don't want those extra API calls and the logs that it generates to happen. So we make people kind of specify that themselves, just as like a kind of idiot check, I guess. We want to make sure that you're doing that only if you really need to do it. We also don't do GPO local group because actually collecting from computers is always going to be more accurate. If you want to add logged on collection, it's as easy as just putting a comma and logged on after your collection method flag. When we run it defensively, this is exactly how we do it. This is our first run every single time when we're using an admin account. And if you look at what it touches, it's the exact same thing as the default collection method. The only thing that changes is we get more data back. We request more properties from LDAP, but the touches to the computer are exactly the same as they were previously. So my argument is if you're going to run default collection, you might as well just run all collection because they're both really, really loud. And the amount of loudness that all adds does not compensate for how much data you're missing. So use that one. All right, and then the third one I'm going to talk about is DC only. This is something that we added not that long ago, but this was kind of our answer to like how can you make Bloodhound a little bit more stealthy without touching a lot of computers, but still getting a lot of interesting data. We started doing some assessments where we found that even just collecting data from LDAP exclusively, we could find lots and lots of interesting attack paths without ever having to touch any other computers. So the DC-only collection method does exactly that. It excludes all session collection, all direct local group collection, and it only pulls data out of LDAP and from files on GPO drives. This is really like quiet as far as what it's touching on the network. You get one big LDAP pull, but other than that, like that's pretty much the gist of it. So all it touches is a domain controller, and wherever the GPO files are stored, which in most environments is also the domain controller. So running DC only is a good way to get a really big chunk of data and start like really analyzing a network without actually going out and like creating a lot of noise by touching every single computer. Generally, the only way this would ever get caught is some NetFlow monitoring to see large LDAP pulls, or if someone has specific event rules in place for detecting Sharphound, which in that case is going to get caught no matter what you do. So I don't want to worry about that too much. All right, so Sharphound has a stealth flag, and it's a little bit confusing because when we first released Bloodhound, stealth was its own collection method. When we released 2.0, we decided that stealth should be a modifier for collection methods. So you can specify whatever collection methods you want, and if you add the stealth flag on top of that, it will modify how those collection methods work. So the really big things that changes are how sessions are collected and how local groups are collected. But when you do stealth, sessions will be limited to file servers, which we determine by using LDAP, and domain controllers. On an average environment, you're probably looking at like 15 or 20 computers being touched when you use the stealth flag as far as session collection. But in our experience, those 15 to 20 computers account for somewhere around 60% of the sessions you're going to see on an environment in the first place. So 60% isn't great. It's a fail, but 60% will still get you a really good start in without creating a lot of excess noise. We actually have some really cool lesser known options that you only literally find if you dig into the source or you go through the help file, which no one does. And we've added these over time for different purposes. One of them is the exclude DC flag. We added this actually entirely as a bypass for ATA. We had a little back and forth game with the ATA for a while, and ATA was like, yeah, we got Sharphound down. I was like, well, you guys only run on domain controllers now, so we just don't touch a domain controller, like you can't see us anymore. And as of our last time we tested, this actually still works because the newer flares of ATA just use a domain controller tap to do all their detection. The LDAP filter parameter, this actually will take whatever LDAP filter you give it and just tack it onto the end of the giant Franken filter we built earlier. So if you want to help create Frankenstein's monster, you are perfectly free to do so. But this is a really good way to filter down your query to like specific OUs or like specific descriptions or whatever you may want to do. LDAP is really flexible, so you're free to change that however you want. The ping timeout flag, this by default is set to 200 milliseconds, and ping is kind of a misleading word because it's really a port scan. We check if port 445 is open before we do any API calls on the computer. The reason being, if you do an API call against a computer that's dead, it takes like literally 15 to 20 seconds to come back and tell you it's dead. So we save a lot of time by doing this. But if you're running this on like a big global organization, you're gonna wanna up that setting because when you're traveling over like long links and stuff like that, 200 milliseconds might not cut it. The last few options here are like really OPSEC, throttle and jitter. Those are pretty self-explanatory. We do have a cache file with Sharphound, which speeds up future runs. If you don't need it, if you're not doing multiple runs on the same computer, just use no save cache. There's one less file dropped to disk. So, and random file names, because some EDR solutions thinks it's a good idea to signature on file names dropped. So we just nip that in the bud. All right, this is a list of like all the collection methods that are available. The first row are hybrid ones, which include multiple, and then the other ones are the individual ones. We're not going to cover most of this. This is a reference slide. You guys can look at this later. We'll publish the slide deck when we're done. All right. So we have an example attack path that we want to show you guys. I'm going to pass this off to Andy.
So, like Rohan said, one of the things we want to do in this talk is show off some of the cool new attacks that we've added to Bloodhound recently, which these are all based on work by other people. But they are attacks that met the bar for us for inclusion into the project, which means the data that you can, or the data you have access to as a domain authenticated user, you can enumerate these attack paths. They are things that are not exploits. They are just built-in configurations or misconfigurations in Windows or Active Directory, so it's very unlikely that Microsoft is ever going to change the behavior of those configurations. And they are extremely reliable because they have been, so to say, weaponized by folks as well. So we're going to look at all of that based on this attack path right here. So this attack path, not sure how big that is on the screen, but it starts off at the jfrank user, which is Jason Frank. Thank you very much, Jason. And we are targeting on the very far right a computer called MSSQL 001. And let's say, for example's sake, that on our red team objective, getting access to the data that this MSSQL instance contains was our objective. So we're not getting DA, we're getting data access. So this attack path starts off with Jason, who belongs to two different groups, and through that group membership, Jason has the right owner privilege against this user called Bob Accounting. Bob Accounting has an edge connecting him to the Accounting 001 computer called Allowed to Act, which we will explain what that means. Then that computer has a user logged onto it named SQL 2014. So that's our, favorite example of running Memcached and getting credentials or injecting into a process with a primary token for that user, etc. And finally, that user SQL 2014 is a SQL admin on this computer called MSSQL 001. So across all of the possible edges and configuration abuses that Bloodhound tracks, we're going to focus just on these right here. Which I guess the point of that is to say that there is a whole world of possible abuses that Bloodhound tracks in case you're not familiar with the tool. And we have documentation for each of these in the tool and in blog posts. Let's talk about Kerberoast. So in this example attack path, let's say that we have a shell in a system and we run Bloodhound and we say, show me a path from my user to the SQL box or the domain admin or whatever. And we get that really annoying pop-up at the top that says no data returned. I hate that. So are we done? Like, is that it? Like, is that the end of the assessment? Of course not. So there are other ways that you can start your attack that don't necessarily require your initial access user to have any sort of special privileges that are tracked by Bloodhound. Think about Kerberoast as an example. Kerberoast is based on original research by Tim Medine. Is Tim in the room? Don't think so. If you see him, give him a handshake. Kerberoast basically revolutionized red teaming for us, changed a lot of how we do our very initial reconnaissance efforts and initial lateral movement efforts, and it's, again, an extremely reliable attack, so we include it in the Bloodhound project. The long and the short of Kerberoasting, if you are not familiar, is that Kerberoasting allows you to do offline password cracking by any domain authenticated principal against any user that has a non-null service principal name LDAP attribute, okay? There are some caveats to that, which if you look at Will Schroeder's talk from earlier today, you'll see what those caveats can be, and we'll update this deck with the link to his talk when that's done. So Kerberoast is great. Love it. Swear by it. It's incredibly dangerous from the defender side, and it can be very difficult to figure out what your, so to say, hit list of remediation is for that if you don't have access to this data. But there's one very, very big problem with Kerberoast, and I will let you sit in suspense as I drink some water. So the problem with Kerberoast is that we have finite password cracking resources. And sometimes you have a wealth of users that you can choose from to Kerberoast, And you may know what privilege they have or you may not. If you don't, then you can guess what kind of privilege they have based on group membership, based on what systems they use frequently, or based on maybe the description in the user object or something like that. And so what does that translate into? That means that we're wasting effort on low privilege accounts by doing parallel offline password cracking efforts across many different users. That also means that there's limited key space you can explore per hash that you're trying to crack. So what if you're doing key space of 1 through 6 characters that are printable, but the domain admin password was 7 characters long? And you didn't get there because you were focusing on all these other accounts that don't matter. And this affects you. Whether you have 2 Kerberoastable users, if you have 200 Kerberoastable users, or if you have 20,000 Kerberoastable users, which we have seen. Good Lord. So Bloodhound lets us intelligently prioritize that password cracking effort, which I'm going to show you exactly how we can do that. So first of all, if we look in the Bloodhound GUI, there are some pre-built queries that can help us figure out what users are worth going after and which ones are not from a Kerberos perspective. And one of the really easy wins is come over here to the pre-built queries. This is, of course, after you've done your data collection with SharpHound and imported the data into the database. And if we look at shortest paths to domain admins from Kerberoastable users, if you click on that, it will tell you what domain do you want to select. So we select Contoso, and that will run a query on the backend database and say any user that is Kerberoastable, or in other words, has an SPN, is there an attack path from all those users or any of those users to domain admin? And of course, we can see that there are several. And if we click on one of these, let's pick on Jason. That's my favorite thing to do recently is pick on Jason Frank. So if we look at Jason, there's a whole bunch of information that we get from AD about this user, including the last time that Jason changed his password, which was, what year is it? 2019? 16 years ago. I don't know if Jason's even that old. And of course, Jason has a path to domain admin. And because his password is so old, that at least tells me that, based on password best practices from way back in the day, and even some that currently exist, it's pretty likely that Jason has a pretty bad password. I also look at him, you can tell.
He's management.
He's management, yeah. His password is probably password 1. Please don't hack us. So something else we can do is, let's say you buy into that theory that the older the password is, the more likely it is that you'll be able to crack that password. What we can also do is look at shortest paths from Kerberoastable users, and again, select our domain. This will populate a list that is all Kerberoastable users sorted in descending order, where the further back their password is, the higher up in the list they will be. So in fact, we have this user right here that their password changed in 2002. And if we click on this user, Bloodhound will say, from that user, how far can you go into the network? And of course, from this user, we've got tons and tons of options. But let's say, for example, that one of those caveats applied to that user that Will talked about in his talk earlier today. Or say that you know that account is very heavily monitored, or you know that if you use that account and there's a logon for that user on some other system, that's going to trigger an alert. So the interface is a little bit limited right now as far as this kind of analysis. So what we are going to do is roll our sleeves up. And my message to you is, don't be afraid to do that. So on the left, we have the Jason Frank Active Directory object. And you can see that he has a attribute set where it says service principal name foo/bar. It doesn't matter what this is, as long as it follows that format, it will be, so to say, valid. When SharpHound finds a user that has a service principal name set, it internally has this Boolean value on the node in the Neo4j database, and the name of that property is hasSPN, and in this instance it's set as true. By default, every user we add has this attribute set as false until we find users that have SPNs. What we also do is put a list value on the service principal name attribute to list out what all those SPNs are as well, because there's all kinds of great intelligence you can glean from that. So, what if we want to get a count for how many Kerber roastable users we have? We can do that with a little bit of Cypher, and I'm going to show you exactly how this works. So this is the Neo4j web console. By a show of hands, who has looked at this? Great. Who likes Cypher? I'm putting my hand up as high as I can. So let's just copy and paste this. And what we're doing is we're saying, I want to match any user labeled node, and I'm going to apply that to the variable called u. And I'm going to constrain that to users where the has SPN attribute is true. Then I'll return a count of how many users came back, and I have 65. If I have a week of password cracking power and I have 65 Curb5 TGS tickets to crack, I'm doing something wrong. What else can we do? We can limit our search result to just the Kerber roastable users that have a path to DA, or a path to enterprise admin, or a path to a domain controller, or a path to whatever you want. And so the way we do that is, again, we match any user that has an SPN. Then we match the domain admins group in the Contoso domain and apply that to the variable lowercase g. Then we have a pattern where the variable is going to be p, and the pattern statement is shortest path from u variable to g. And this will start from every single user that matches that variable and find a path from each of those two domain admins. Then we'll return the name of the user and the length of the attack path so we can see who's the closest to domain admin. And we'll sort that in ascending order. So let's do that. Okay, so what we get back is a nice little list. So at the very top, we have this user called S Starbuck, and its length of its attack path, so to say, to domain admin is 1. That means there is one relationship separating that user from the domain admins group. And that could be, it's a member of the domain admins group, it has control of the domain admins group, or whatever. More than likely, it is a domain admin. And as you scroll down, you can see that the attack paths get longer, which means they're going to be more complicated, which means that it's going to give defenders more opportunity to detect each of your attack path steps as well. So what if we don't have any Kerber roastable users that have a path to domain admin? Well, we still have plenty of really juicy data in the Bloodhound database to help us out. So instead of finding just Kerber roastable users that have a path to domain admin, what if we look for the most privileged Kerber roastable users based on how many computers they have local admin rights on? You can do some slight modification to this to have it be control of AD user objects instead. So let's look at what this looks like. I don't want to explain this one too in depth because I'd be up here for about 30 minutes explaining it. If you want somebody to explain it to you, Matthew Saulnier is right here in the front row, Scooby, and he'll be happy to explain to you what it means. So we run that query, and sure enough, this S Starbuck user comes up at the top, and the count of computers that this user has admin rights on is 511, which is the number of computers that we have in this database. And then scrolling down the list, you can see that the number of computers that each user has admin rights gets fewer and fewer and fewer and fewer until you get to the very bottom where it's J. Frank, right where he belongs, right at the bottom of the list. So from all of this right here, like if I'm on a red team and I want to have really good success with Kerber Roast, there's a whole bunch of different angles that you can look at to kind of heighten your chances of success. And also maximizing the value that you get out of your password cracking capability. A lot of times on a red team assessment, that may just be the GPU in your laptop. Or it may be like a 20 GPU system that your employer has purchased and put into a rack somewhere, or maybe more, if you're really lucky. Either way, as we get to a key space that covers more character length of a password, we of course see complexity that rises tangentially. So making the most of your password cracking effort matters regardless of what your situation is. So we're going to hand wave this a little bit, and we're going to say that we Kerber roasted Jason Frank, and we got his password. There have been lots of presentations that tell you how to do this operationally. There's a lot of good writing that will tell you how to do this from several different resources. Rob Fuller, Sean Metcalf, Will Schroeder, and the Black Hills InfoSec guys have lots of really good documentation about that. It's a little bit outside the scope of what we're talking about, so if you don't know how to do this actual attack, go to one of these links or go to all of them and see for yourself how to do it. So now we're going to go to the next step in the attack path. We're going to say, okay, we know Jason Frank's password now, so next we're going to abuse that right owner privilege that he has over the Bob accounting user, and Rohan's going to show you how to do that.
All right, so we're actually covering this edge in particular because it's kind of a cool one. A little known fact about Active Directory objects is that every single object in Active Directory has an owner that's associated with it. Most of the time that ends up being the domain admins group. But the interesting part here is that the owner of an object has the ability to modify the access control list of an object regardless of any other ACEs that are on there. Even if there is an ACE in the ACL that specifically denies you from changing the ACL, because you're the owner, you can just bypass that altogether. So if you have the ability to write the owner of an object, you can change that owner to whatever you want, at which point you have full control of the object. So that's exactly what we're going to do here. Because we're a member of the IT 00035 group, I don't know why Jason's an IT group, but these things happen. People mess up their AD all the time. We have the ability to write owner on the bob.accounting user. So our attack path that we're going to execute here is first we're going to use our write owner privilege to change the owner of bob.accounting to Jason Frank. And then from there, we are going to grant Jason Frank, the user we already control, the ability to completely change bob.accounting's password without knowing their current one. This is a right you often see help desk groups have. If you've never audited your help desk group rights and who has control over them, you should do that, because when you can reset the user any password in the domain, you're basically a DA at that point. Then we're going to change Jason Frank's password without knowing his current one. Oh yeah, sorry, Bob Accounting. We're going to change Bob Accounting's password without knowing it currently, and Bob Accounting is going to go complain to help desk that he locked out his account by accident. But in the meantime, we're going to utilize his rights to do what we need to do. All right, so we got a little video here of how this looks like, and we're going to be using PowerView for this. If you're not familiar with PowerView, you should definitely be familiar with PowerView. And the first thing we're going to do is use the set domain object owner commandlet. And all this does is it changes the owner of an object to whatever we specify. So we're going to say the owner of bob.accounting is now J Frank, who we control. Then we're going to use add domain object ACL and get the right reset password, which translates to force reset password in the Bloodhound schema. After that, we are going to create a string with the password DerbyCon 2019 bang. Very, very secure. No one will ever crack it. And then we're going to, again, use PowerView to directly set the password of the bob.accounting user to this new one. So at this point, we now know bob.accounting's password, so we are bob.accounting. All right, and look at that. Just like that, we're on the next step of our attack path. That was a nice quick one right there. So the next one is actually going to be some really fun new stuff that came out not too long ago. And I'm going to go ahead and pass this right back to Andy.
Yeah, so we are hand waving some stuff, but if you're not sure how to create a token for yourself or create a process for yourself or otherwise get into a user context as a user that you're not currently running as interactively, come talk to us and ask us. We're going to be at the SpectreHouse booth after this, and we're happy to tell you about that. But for the sake of brevity, we'll just say that we are now impersonating bob.accounting. So, allowed to act. This is shorthand for allowed to act on behalf of other identity. That's clear as mud, right? So this is based on original abuse research by Elid Shamir. There's his Twitter handle right there. And then this research that Elid put out was made practically abusable by Will Schroeder using Rubius. So this comes from an attribute on the LDAP object, and the name of that attribute is MSDS allowed to act on behalf of other identity. Everybody got it? All right.
There'll be a quiz later.
There's some resource links at the bottom as well, and the deck is obviously going to be available after the talk. So here's the piece of the attack path. So Bob Accounting is allowed to act to accounting 001. What does that mean in English? So the user, Bob Accounting, is allowed to act on behalf of other identities to the computer accounting 001. In other words, the user, Bob Accounting, is allowed to impersonate other identities to the computer accounting 001, or put a third way, this computer trusts Bob to impersonate anybody else against any service that that system hosts, including, I don't know, SMB, RPC, etc. The bottom line is it's Kerberos delegation. And this specific flavor of Kerberos delegation is called resource-based constrained delegation. So our plan of attack with this edge is we want to determine, first of all, who is it that we want to impersonate? Now, keep in mind, we can only impersonate to that computer itself. So we want to pick somebody who has admin rights on that system so we can abuse that. Some caveats with that. This account cannot be marked as sensitive and cannot be delegated. It cannot belong to the protected users group, and the account needs to be privileged on the target. I can tell you from personal experience that these first two are almost never a problem because these configurations are not very well understood by most AD admins in our experience. So just be aware of that when you actually do execute this attack. Okay, so that's step one. Pick out who we're going to impersonate. Step two, impersonate that user. Easy. Step three, execute privileged commands on that target computer. All right. So if we're going to pick a user that we want to impersonate, we can use the Bloodhound interface to do that. And so in the top left, we'll search for that computer, accounting 001, click on it. Then in the local admins dropdown, we can see that there's 20 group delegated admins on that system. So the domain admins is added to local admins, and also this group called IT49. Here are all the users that belong to that group, including at the very bottom, this guy named David McGuire. Is that what that says? Okay, yeah, something McGuire. All right. So let's say that we go through and we find out that, okay, yes, David does not belong to the protected users group. His account is not marked as sensitive and cannot be delegated, and we kind of honestly don't really think he's that important, so people are probably not monitoring actions with his account. If you don't know, David McGuire is our CEO. So the actual attack, okay? So we're going to use Rubius for this, put up by Will Schroeder. And so who am I? We're Bob Accounting. Host name, we're on desktop 001. So let's try to dir out the $C share on accounting 001, which by default you must be an admin to do. And of course we get access denied. So first thing we do as part of this step is calculate the NT hash for the password of Bob Accounting. And Rubius does that very, very easily for us. So here's the NT hash, or the RC4. We'll copy that and put that into our next command, which is going to do the actual S4U process to get a TGT that will be valid against that system. And then at the very end, we're doing /PTT, or pass the ticket. So we're loading that ticket directly into memory. We, of course, could take that ticket somewhere else and use it somewhere else. So we finish that. We see ticket is successfully imported. And we'll try to dir the $C share again on accounting 001, and of course we see that we can. So now we are impersonating David McGuire to that system over SMB, and because David is an admin, now we can laterally move over to that system using psexec, WMI, DCOM, what'd I miss? PowerShell remoting, WSMan, whatever you want. There's 1,000 ways to skin that cat, and there are more coming out all the time. All right, that brings us to the last step in this attack path, which is the SQL admin edge, and Rohan's going to talk about that.
All right, so the SQL admin edge is one of the newest edges we've added. Actually, it is the newest edge we've added to the Bloodhound schema, and this was a pretty recent thing that we came up with after sitting down with a couple of the NetSpy guys, and he was like, "Yeah, you know, you can just do this, right?" And we were like, "No, we didn't. Like, why would we know that?" And he's like, "Yeah, so you should add that." So we did. All right, so what creates this edge? when you run the SPN targets collection method, which is, again, very new, it's included in all by default. So if you're running all collection, you're going to get this anyway. But if you just want to do this, you can run SPN targets. SharpHound, when it encounters user objects with a service principal name, will look at those service principals and see what they are. And it will, if it finds something that looks like MS SQL / something, it'll kind of save that off and say, this is something we need to take a look at. Once it takes that, it kind of parses it out into a host name, and we check on that host whether the SQL port that is in the SPN is available. And if it is, we say, all right, it's a very high % chance that there is an MS SQL server here, and there's a good chance that we're going to be able to do something with it. Big shout outs to Scott Sutherland, Carl Fossen, and Eric Gruber, and all the NetSpy guys who worked on PowerUp SQL, because they killed it, and this is awesome. All right. All right. So what does this functionally mean? When you set up MS SQL, there's multiple different ways to do it, and one of them is to configure it using a user account. Now, obviously, if you configure it using a user account, you don't want to have to log in every single time to start that SQL instance. So Active Directory is happy to facilitate that for you by using a service principal name. When you set up MS SQL as a user account, that user account is given a service principal name in AD so that the Kerbos ticket can be grabbed by the service itself and used to start up SQL. Now, this isn't 100%, but it's pretty close in our experience. The user that was used to start the service is almost always a sysadmin on the SQL instance that was used. Because if you're setting it up as a user, you're probably just like setting something up really quickly, or you are the admin for that box. So a lot of times that just gets added in. If you have MS SQL sysadmin rights on a MS SQL instance, there are tons and tons and tons of different things you can do. Exploiting MS SQL is not new. People have been exploiting MS SQL probably since the dawn of time. And you can leverage that sysadmin access to run commands on the host very often as a very privileged context. So we're going to use a good old XP command shell, the oldest trick in the book. And there is tons of MS SQL research, again, in PowerUp SQL. And there's probably 50 different ways you can execute code using that tool alone. So if you want more info, there's a link to PowerUp SQL on the bottom. Definitely cool stuff.
So yeah, XP command shell is the most obvious, and there are several different scripting subsystems in MS SQL that can be enabled. So Python, R, probably some other one that I'm not thinking of. Yeah, you can also do stored procedures with MS SQL, so you can actually evade command line logging this way by remotely loading your assembly using MS SQL statements, which is magic. So anyway, our plan of attack was SQL admin. So step one, we need to confirm that the MS SQL instance is actually accessible. Then we want to confirm that our user actually is a sysadmin and has the privileges that Bloodhound is telling us that it has. And finally, we'll execute code on that target system. We're going to use PowerUp SQL for all of this. Okay. So here we are running as the SQL 2014 user, which we got access to because Dave McGuire was an admin on that system. We're going to load up PowerUp SQL. And we want to make sure the MS SQL instance is actually accessible. So we're going to use this PowerUp SQL commandlet called get SQL instance scan UDP, which will do a UDP scan against the system that you specify on port 1433 by default, and then I think it will dynamically look at other ports as well, perhaps. I don't know. Scott can correct me if I'm wrong. But we can see there's actually two different instances of MS SQL running on this system. Currently, we don't import that data into Bloodhound, so this is why this is very important if you are executing this attack path using Bloodhound data. So we have MS SQL Server and MS SQL Server 2. So we need to figure out, are we a sysadmin on one or both of those? So we'll do get SQL sysadmin check against the instance hosted on Win2016-SQL 2014 /MS SQL Server. There's no output, which means that No, we are not a sysadmin. So let's try MS SQL Server 2, that named instance. And now we see yes. So in this object that comes back, one of the attributes is sysadmin, and the value of that is yes. So we are a sysadmin. So now let's verify that we can actually execute commands on this system. And for this, we'll use invoke SQL cmd against that instance, and we're just going to use the whoami command. And the command results, we see that we are in fact running as Contoso backwack SQL 2014. Okay, that's great, but I'm more interested in getting access on a system where I'm also a local admin. So let's say, for example, we don't have that data in our Bloodhound database. You can confirm local admin access right here without having to leave this window. So one quick way to do that is the net session command in Windows. By default, you must be a local admin to access that data locally, not remotely for some reason. But on this system, running a SQL 2014, we do net session and we see access is denied. That's because we're not a local admin. So with our power up SQL command, we'll just change whoami to net space session. And we'll see there are no entries in the list. So if you ever used the @ binary back in the day, this is very similar to that. So when you see there are no entries in the list, or if you actually get file sessions as output here, then you know that you are a local admin on that system as well, or at least 99.9% chance you are. At that point, now you're ready to laterally move to that system using this privileged command execution. There's 1,000 ways to do that. You could do a PowerShell download cradle. You could do bits admin. You could do credential relaying from that system to you. There's tons of ways you can abuse this. And if you look at the Power Up SQL wiki, you'll see lots of different examples for what you can do with this step.
All right, so in a nice 15-minute presentation, we just went from starting as a useless user like Jay Frank and moving all the way over to the treasure trove information that is on MS SQL 001, which I'm sure is like PII or something. And in this entire process, we actually never touched a domain admin. We just used different users that were privileged in some way. So, you know, just one thing we always like to say is domain admin isn't everything. Sometimes you just don't need it. But yeah, at this point, we've executed an attack path that includes all the newest hotness that we have. And we won, and we're happy, and the sysadmins are hopefully happy, because otherwise we're not getting hired back again. But other than that, like this was fun. Like, we had a good time executing this, and the client is like, "Whoa, that's so cool! Who did that research?" And we're like, "It was all me." All right.
So I think we have time for maybe 2 or 3 questions. Right over here.
Okay, so by default, when we do session collection, his question was, when you use the logged on collection method in SharpHound, what does it give you that you don't get normally? The normal API call we use is net session enum, and what we're asking a computer is who has network sessions to you. When that data comes back, it comes back with an IP address or a host name and a username without the domain, which forces us to do some guesswork and kind of figure out, like, I think it's this user. So the has session edges always have a degree of like ambiguity, whereas with logged on, we're actually asking the computer who is logged on to you from the registry, and it actually will give us all that information back because we're privileged, and all the information is in the format we need. It has all the data, so there's no guesswork involved, so it's much more accurate. And because we're getting the direct logged on users, we're not relying on network sessions or anything like that. So it's much better and much more accurate. Yes.
It's getting a little bit loud in here. We'll do one more question, and then Rohan and I are going to go to the SpectreOps booth if you have other questions. However, we have Bloodhound stickers up here after we answer this gentleman's question right here in the green shirt. So his question was, are all the new features in the PowerShell version of the data collector? So the PowerShell data collector is the C# data collector. So the C# data collector, we turn that into a base 64 binary blob, and then load that up with PowerShell. So it is the exact same thing.